Hello students, welcome to Engineers Academy. Do hit the subscribe button if you are here for the first time. Now we are going to solve this problem from Fundamental of Physics by Resnick Halliday. And the problem says that if a particle position is given by this function x equals to 4 minus 12t plus 3t square, where t is in second and x is in meters, what is its velocity at t equals to 1 second? In part B, it is said that is it moving in the positive or negative direction of x just then? What is its speed just then? And in part D, it is said that is the speed increasing or decreasing just then? And further, it is said that try answering the next two questions without further calculation. In part E, it is said that is there ever an instant when the velocity is zero? If so, give the time t. If not, answer no. And is there a time after t equals to 3 seconds when the particle is moving in the negative direction of x? If so, give the time t. If not, answer no. So we are given x as a function of time, the position of a particle as a function of time. So 4 minus 12t plus 3t square. In part A, we are required to find the velocity. What is the velocity at t equals to 1 second? So the rate of change of the position, velocity is equal to dx by dt. So we need to take the derivative of x of t function. So the derivative of this will be, the derivative of 4 is 0. This will give us minus 12 and 2 into 3 is 6. So minus 12 plus 6t. So this is the velocity as a function of time. Now we want to find the velocity at t equals to 1 second. So we need to substitute t equals to 1 in this equation. So the velocity at 1 second is minus 12 plus 6 into 1. So minus 12 plus 6, and this is minus 6 meter per second. This position is in meters. So the velocity at t equals to 1 second is 6 meter per second. This is the answer to the first part. Now in the second part, it is said that is it moving in the positive or negative direction of x? So as we can see that the velocity is negative. So the particle is moving in the negative direction of x. Let's say if this is the position line and towards the right is the positive, then towards the negative, towards the left is the negative. So the particle is moving in this direction. So in part B, we will say that it is moving in the negative direction. So negative direction. Now in part C, it is said what is its speed just then. So the speed is always equal to the magnitude. So we can say that the speed will be equal to the magnitude of the velocity, and the magnitude of the velocity is 6 meter per second without the directions. And so the negative sign tells us the direction of the velocity. So without the direction, the speed is always positive and the magnitude of the velocity is always the speed. So 6 meter per second. And in part D, it is said that is the speed increasing or decreasing just then. So now let's say that at t equals to 1 second, the velocity is 6 meter per second. Now let's say if I substitute t equals to 1.2, let's say in this equation. So t equals to 1.2, let's say minus 12 plus 6 into 1.2. So the velocity is minus 4.8. So this means that after t equals to 1 second, the velocity is decreasing. Since at t equals to 1 second, the velocity magnitude is 6 meter per second and it is towards the left. So at t equals to 1.2, the particle is still going in the left, towards the left, but the magnitude of the velocity is decreased, that is 4.8. So from here we can say that is the speed increasing or decreasing just then? So we can say that the speed is decreasing. So for part D, the speed is decreasing, and we can find the t value for which until that point the velocity is decreasing. So let's say or we can say that we can find the t value at which the velocity will become 0. So if we equate this equals to 0, then we will be able to find the time t at which the velocity will become 0. So we can say that minus 12 plus 60, this is equals to 0, and from this we can say that 60 equals to 12 and t equals to 2. So at t equals to 2 seconds, the velocity is 0. So the velocity is 0 at t equals to 2 seconds. So this means that if the velocity at t equals to 1 second is minus 6 meter per second, so the particle still continues towards the right until its velocity becomes 0, and after 2 seconds the velocity will become 0. So then in part E it is said that is there ever an instant when the velocity is 0? Yes. If so, give the time t. If not, answer no. Right? So at t equals to 2 seconds, the velocity becomes 0. So in part E we can say that yes, there is an instant when the velocity is 0, and at t equals to 2 seconds, the velocity is 0. V equals to 0. Now in part F it is said that is there a time after t equals to is there a time after t equals to 3 seconds when the particle is moving in the negative direction of x? If so, give the time t. If not, answer no. So now if we observe all this calculation, so we can draw just an approximate graph of this x of t. So let's say this is my positive x and y axis. Let's say this is t and this is x. T is in second, this is in meters, and we can say that the velocity is equals to 0. So at t equals to 2 seconds, the velocity is equals to 0. So let's say that somewhere is 1 second, this is 2, and somewhere is, let's say, 3. So this is 1, 2, this is 1, 2. So since it's a quadratic function and we have plus with the coefficient of t square, so the function is concave up. The function is like this. So the function is like this, and at t equals to 2 seconds, the slope of the quadratic function will be straight line, since the velocity always tells us the slope of x of t function. So we can say that the graph will somehow look like this. So there will be one minimum point, and that one minimum point occurs at t equals to 2 seconds, where the velocity is equals to 0. When the velocity is equal to 0, the tangent to the curve will be the horizontal line. So now from this we can say that the answer for this will be that is there a time after t equals to 3 seconds when the particle is moving in the negative direction? So no. So until t equals to 2 seconds, the particle is moving in the negative direction, that is towards the left, and after that it is going in the positive direction, since the x of t function is like this. So the slope is negative, 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 and then it becomes positive, positive, positive. So this means that there is the particle is moving in the positive direction after t equals to 3 seconds. So for F we can say that no, there is no such instant after t equals to 3 seconds when the particle is moving in the negative direction. So initially we can summarize this. Initially, if we draw the particle position as a number line, let's say this is 0 meters, and if we substitute t equals to 0 in this equation, so this will become 0, this will become 0. So initially the particle was at x equals to plus 4 meters. So somewhere here is the particle at plus 4 meters, and it is moving towards the left, and at t equals to 2 seconds, the velocity becomes 0. So the velocity becomes 0, and then it turns back, and then it turns back, and then it continues motion, its motion towards the right in the positive direction. And we can find that particular position where it turns back, since we know that the velocity at t equals to 2 seconds is 0. So then at this particular point, when its velocity become instantaneously 0, at that particular moment it will turn back. So if we substitute t equals to 2 seconds in this x of t, we will be able to find the position of the particle at t equals to 2 seconds. So 4 minus 12 into 2 plus 3 into 2 square gives us minus 8. So this particular position is minus 8. So at t equals to 2 seconds, here the time will be 2 seconds after that initial position. So at t equals to 0, the particle was at 4 meters position, and then at t equals to 2 seconds, it was at minus 8. And at this particular point, the velocity is 0, and then it turns back towards the right, and then it keeps on its motion in the positive x direction. So this is the solution of this particular problem. I hope this will help you in your learning. Do like this video and subscribe Engineers Academy for the solution of such more problems from Fundamental of Physics by Resnick Halliday.